Hello everyone, in this Thierry Sicard tutorial number 23, we will analyze the closed-loop transfer function for a non-inverting and inverting amplifier. We start the analysis with a non-inverting amplifier. We define the feedback ratio K equal R1 over R1 plus R2. So the feedback voltage on the inverting input is Vf equal K times Vout. Based on those definitions, we can do the closed-loop transfer function with the error voltage epsilon equal to Vin minus Vf, multiplied by the amplifier gain A. The output voltage Vout is multiplied by K ratio to get the voltage feedback Vf. For the calculation, we start with Vout equal A times epsilon, replacing epsilon value by Vin minus K Vout, we get Vout equal A Vi minus AK Vout. So Vout times 1 plus Ka equal A Vi. The closed loop gain Vout over Vin equal A over 1 plus AK. If the open loop gain AK is much greater than 1, the gain Vout over Vin equal 1 over K, or 1 plus R2 over R1. Now we will do the same analysis with the inverting amplifier. As the error input epsilon is function of Vin and Vout, we need to use the superposition theorem. When Vout equals 0, epsilon equal Vi times R2 over R1 plus R2. But when Vin equals 0, epsilon equal Vout times R1 divided by R1 plus R2. So the error voltage epsilon is function on Vin and Vout. In the epsilon equation, we recognize the factor K equal to R1 over R1 plus R2 as the one used in the non-inverting amplifier. But we need to define a second one, K prime equal to R2 over R1 plus R2. So we can write down epsilon equal Vi prime plus Vf, where Vi prime equal Vi times K prime, and the feedback voltage Vf equal K times Vout. In comparison, the epsilon in the non-inverting amplifier is equal to Vin minus Vf. In the non-inverting amplifier, the epsilon error is done with the totality of the input voltage Vin. In the inverting amplifier, the epsilon voltage takes just a part of Vin. In the non-inverting amplifier, the epsilon is the difference between Vi and Vf. In the inverting amplifier, the epsilon is the sum of two voltages. But in fact, the sum becomes a difference because the gain in the inverting amplifier is minus A, due to the fact that epsilon is driving the inverting input. So, in both cases, Vf equal minus AK epsilon. The calculation of the inverting amplifier gain starts with the gain Vout over Vin prime. So Vout equal minus A epsilon. Replacing epsilon, we will get Vout over Vi prime equal minus A over 1 plus AK. As Vout over Vin equal Vout over Vn prime multiplied by Vi prime over Vi. The final gain is minus AK prime over 1 plus AK. We have to note that both circuits, inverting and non-inverting amplifier, have the same closed loop except the sign. Vout over Vin equal Vout over Vin prime. So when AK is much greater than 1, the gain equal minus K prime over K instead of 1 over K for the non-inverting amplifier. At the end, minus K prime over K equal minus R2 over R1 and 1 over K equal 1 plus R2 over R1. I want to thank you for your attention. On my next Thierry Sicard tutorial number 24, based on this closed-loop transfer analysis, we will review the stability analysis difference between inverting and non-inverting amplifier. So see you soon and stay tuned.